So now let me give you one more definition, which is something, which is also very important. I mean, this is there's something called certainty equivalent of a lottery. Okay, so let me give you that definition. Okay, so for a particular individual, what is a certainty equivalent of a lottery? Okay, how do you define that? Okay, so for you, okay, utility function u, of course, individuals preferences are represented by utility functions, right? So for individual whose utility function is u, remember, whenever I'm using small u, I'm just using Bernoulli utility function, because the thing is that Bernoulli is enough, right? I mean, once you know Bernoulli, it's just expected utility. So capital U is something which follows straight from, if you know small u, you know capital U. Is that okay? So for small u, okay, certainty equivalent of lottery X is the amount Cx in R plus such that the following holds. Okay, so I'll give you, what condition is required for certainty equivalence. Okay, the satisfaction level associated with this certain amount is equal to the expected utility of X. So it is that certain amount, which you are indifferent to compared to the lottery, which gives you the same satisfaction level as the lottery itself. Okay, notice that for risk neutral individuals, the certainty equivalent is the expected value of the lottery. Certainty equivalent is expected value of the lottery. For risk averse individuals, it will be smaller than the expected value. Okay, fine. So let me just show you in picture what is certainty equivalent. Okay, so let's say this is some risk averse individual. Okay, so I'll just draw some picture. Okay, this is a graph of small u. Is that okay? So we have wealth levels on the horizontal axis, the satisfaction level on the vertical axis. Is that okay? Fine. Suppose I consider this lottery, which gives me 0 with probability half, and let's say this amount 100 with probability half. Okay, consider this lottery. Fine. Okay, so if I just connect them by line, I'll tell you why I did that. These 2 points. Okay, this is the utility associated with 100, right? This is a utility associated with 0. Okay, and we have a lottery which gives me 100 with probability half and 0 with probability half. I mean, just for the illustration, but of course this kind of result will hold more in more general situation as well. Okay, so what is the utility from the expected value of the lottery? So expected value of the lottery is somewhere in the middle, right? 50, right? This is the expected value of the lottery. Okay, not expected utility. This is the expected value of the lottery. Okay, so and this is the utility from the expected value of the lottery. Is this clear?
Yes, sir.
Okay, so if I'll give you 50 rupees for sure, then what is the satisfaction level associated with it? It is this. Okay, so this is, you can say, is u of ex, which is of course u of 50. Is that fine? Okay, this is x. Okay, now where in this picture is the expected utility of the lottery? It is this point. Okay, so this is actually expected utility. Why is this expected utility? So just look at this. This is U0. This is U100. Okay, you have connected them by a straight line. This is just half of it. So clearly, you know, if you want half U0 plus half U100, half U0 plus half U100, it will be just this point. That's expected utility, right?
Yeah.
Yes or no?
Yes.
Is that fine? And clearly, U of EX is greater than E of UX because of this shape, right? Okay, this guy is risk averse. Of course, this is something which is expected. Okay, now if you want to figure out the certainty equivalent, okay, how do you figure out the certainty equivalent? This is the certain amount that gives you the same satisfaction level as the lottery itself. So if I'll give you this certain amount, you will be indifferent between the lottery and this certain amount. And this is of course less than 50.
Yes.
Makes sense? Okay. Have you understood this? This is just like a picture demonstration of what we just did. Is this clear? Okay. So this is EUX. Okay. And then of course, this is the certain amount which will give you the same amount of satisfaction level as the lottery. Okay. So this is U of capital X. Okay. And this is also small u of C of X. Okay, so small u of C of X is equal to capital U of X, which is equal to E of U of X. Is that fine? Okay. So we can actually, you know, we can also compare two individuals in terms of who is more risk averse at this lottery and who is less risk averse. So let me give you that definition. We say that an individual is more risk averse than the other individual at lottery X if the certainty equivalent associated with the first individual is lower than the certainty equivalent associated with the second individual. The guy who's more risk averse will be willing to accept a smaller amount, you know, in return for the lottery. You know, I mean, that's basically he'll be so, like, for example, you know, let's say if I consider two individuals, one who is indifferent between 35 rupees and this lottery, and the other who is indifferent between 40 rupees and this lottery, then the guy who is indifferent between 35 and this lottery is more risk averse because he's willing to accept a smaller amount, you know, compared to the other individual to get rid of the lottery. Is that okay? Have you all understood this? Okay.